Hello, my name is Richard Anthony Marca, and this is the sixth video lecture prep for CSC323. This one is going to be shorter because there's only 4 videos, so I'll go over each one. The first is a very short video, which explains what Docker is. Docker is a tool that packages software into containers that run reliably in any environment. And this helps solve the problem of sharing apps across different systems. The containers exist because apps often depend on specific OS flavors, libraries, or system configurations. And without containers, sharing an app built on one system may fail on another system. And this is different from virtual machines. While Docker containers are similar to VMs, they only virtualize the OS and not the hardware. And the 3 core things about Docker is the Docker file, the image, and the container. Containers can run on multiple machines, multiple clouds, and on-prem environments. And as demand grows, containers can scale reliably across all of them. The second video is more in-depth of what the Docker is, which is, again, a platform that lets you package an application with everything it needs, such as code, runtime, libraries, and dependencies, into a container that runs consistently anywhere. And the container is lightweight, isolated, portable, and fast to start. This video also talks about the issues before Docker, which is using the VMs, which is a lot slower, and that there are dependency conflicts, and how the Docker solves it by introducing containers built from images. Images are immutable blueprints for containers that are built from a Docker file, which uses a layered file system for efficient storage and caching, while containers are running instances of images that are isolated but share the host OS kernel, which can be started, stopped, or removed quickly. It also uses a registry that stores images like Docker Hub, which lets teams share and version application environments. The Docker architecture also involves the Docker client, the Docker daemon, the Docker host, and the registry. The typical workflow for Docker is you write the code, then you create a Docker file describing the environment. You build an image using Docker build, you run a container using Docker run app, you push the image to the registry, and you deploy the container anywhere, whether it be local, cloud, or CI/CD. The next video talks about how to deploy a container image to Cloud Run, where Cloud Run is a serverless container where you bring the container and Google handles everything else. So what Cloud Run does is it runs containerized applications easily, and it already handles auto-scaling, load balancing, and HTTPS, plus more behind-the-scenes features, and there's no charge for idle instances. Starting a deployment begins in the Cloud Run console, where you click Deploy Container and then the service. Selecting the container image is, for example, in the video, they use Nginx. So the service name is left as Nginx. The region and access settings are what they usually use. I tend to use US West 1. And you uncheck the IAM authentication to make services public. The pricing model explained in the video talks about the default use, which is request-based billing, where you pay for container instance time and allocated CPU and memory, and idle instances, which occur no charge. It also talks about port configuration, because Cloud Run needs to know which port to send the traffic to. So for the example provided, Nginx expects port 80. And for deploying, you click Create, and Cloud Run will pull the image, import it, create the service, start one container instance, and ping the port to check readiness. When all is ready, the status checkboxes will turn green. You also can verify the deployment by clicking the generated service URL. where if it works, it should have an output like welcome to Nginx. Before Cloud Run, you would have to manually configure Nginx, the auto-scaling, the load balancing, and the HTTPS endpoints. So Cloud Run indicates with Cloud Load Balancer if you need more configurability. The last video talks about how to develop an environment setup in Google Cloud Run. So you start by updating the development Docker file to install gcloud and rebuild the development container after editing the Docker file, which you use by using Shift-Command-P to reload the window. And then you confirm installation with a smoke test in Bash using gcloud --version. You then create and select a GCP project, and you select the project so all resources are provisioned inside it. You authenticate the dev container by running gcloud init, where you follow the browser login, where you choose an account, enter your password, accept. Then you copy the verification code, return to the terminal, and insert it, where you also select the project you created earlier. The next thing you do is create an artifact registry repository, where you open the artifact registry in the GCP console, where you enable the API for the project, and then you create a repository to store production images, where you should also reload the console to confirm the repository appears. The next step you do is production Docker file, where you add a new file named probably Dockerfile production version. And then you populate it with instructions, which should be the blueprint for producing an image containing apps, dependencies, and OS. The next step is the cloud build configuration, where you add a cloud build YAML file to the project. And this file tells GCP how to build the Docker file for Google Cloud Run. Run cloud build in Bash by using gcloud build submit. Make sure you approve any permission prompts, and after the build is completed, the image appears in the artifact registry repository. It then talks about the Cloud Run service definition, where you create a service YAML file with the content that was shown in the video. And you deploy the service in Bash using gcloud run services replace service.yaml. And you approve enabling Cloud Run on the project, and Cloud Run will return a URL for deployed services. However, when you open it initially, it will show a 403 error because the service is private by default. So the next step is to make the service public, where you create a policy YAML file, as shown in the video, that grants public invocation. And you apply the policy in Bash by using gcloud run services set-iam-policy, your service name, and then policy.yaml, where you then reload the endpoint so that the deployed fast API app is now accessible. And that is it for this video. Thank you, and I will see you next time.